Lakshmi, Navtej, Lavanya, Harshita. Good evening, everybody. So let's start with physics today. Physics తర్వాత chemistry చేద్దాము. Alright? So we've got Navtej, Lavanya, Harshita, Afia, Harshvardhan, Prasad, Shrutasya. Alright. So let's get started. Let's start with ray optics, students. Ray optics లో ray diagrams చూపిస్తాను lenses మీద. Concerning lenses, we'll draw the ray diagrams and then we'll go for some questions. Objective questions. Alright? Here's a convex lens. Object is shown with the yellow arrow. Alright. So now I'm going to figure out where will the image be formed. F1 and F2 are the foci. How do I do? I start with this ray passing through optic center. A light ray passing through the center of the lens does not deviate. Alright, it goes undeviated. I know. So that will go straight like this. Another ray which is passing parallel to the principal axis will pass through. Can you tell me which point will it pass through, students? ఎక్కడి నుంచి పాస్ అవుతుంది? యా గుడ్ ఈవినింగ్ సుసస్య. హలో. ఎక్కడి నుంచి పాస్ అవుతుంది చెప్పగలుగుతారా? రే parallel principal axis. When hits the lens, after refraction, it will pass through which point? Yeah, exactly. Let's see how. It passes through rear focal point F1, this way. So ray parallel to principal axis, after refraction, will pass through rear focal point F1. Now these two rays and another ray through F2 will, after refraction, pass parallel to the principal axis, this way. Now, the intersection of any of the two rays out of the three rays shown is sufficient for us to locate the position of the image. All right. This is how it goes through the optic center, parallel to principal axis, refracts, passes through F1, through F1, passes after refraction, passes parallel to the principal axis. And that intersection will give you the tip of the image. All right, rays are emanating from tip of the object. They will converge at the tip of the image. A real image is formed. Now let's look at this one. When it is at C2, when the object is at C2, I'll use any two of these three rays. A ray passing through optic center goes undeviated, parallel to principal axis, passes through F1, and the image is formed at C1 inverted. All right. Now, when the object is at C2, I could have also used the other two rays. Ray parallel to principal axis, passes through F1. Ray passing through F2, passing parallel to the principal axis. Again, they intersected C1, this way. So I could have used any of the two rays. Out of the three rays, we know, I can use any two rays to trace the image. So when the object is between C2 and F2, yes, Harsha, good. Harshavardhan, exactly, that's of the same size. And at C, a real inverted image of the same size is formed. At C2, C1, sorry. But how about this one when it is between C2 and F2? One ray passing through F2 will refract and go parallel to the principal axis. A ray parallel to the principal axis after refraction passes through F1. Now the image is pushed away from the lens, this way. So real inverted image is formed at beyond C1. When it is at C2, when the object was at C2, image was formed at C1. But now it's beyond human. Yes, enlarged. Yes, Harshavardhan. It's enlarged, magnified, or in other words, it's magnified beyond human. Correct. Now, when it is between optic center and f2, now this is interesting. And this is how we use convex lens as a magnifying lens. When the object is between f2 and the optic center, yeah. So where is it? Where is it? Behind the. No, there's no mirror, Harshavardhan here. Lavanya, there's no mirror here. It's a lens. Students, there's no mirror here. Correction. Students are responding, answering that it's a mirror. No, there's no mirror here. It's a lens. Yes, Jhansi. Navtesh. Okay. So this is how it goes. Ray passing through optic center goes undeviated. Ray parallel to the principal axis will go through F1. When I extend these rays backward, this way, dotted lines, the image is shown somewhere here. It's showing the dotted arrow because it's a virtual image. Yes, Sudhasya, that's virtual and erect. That's true. Very correct. Very correct. First of all, it's virtual and there's no mirror here. We're dealing with lenses today. Enlarge. And that's how you see you use convex lens as a magnifying lens. You place the text or whatever you want to magnify between the focal length, focal point, and the lens. And a virtual image is formed behind the lens. All right. For a concave lens, let's see. Again, through optic center, goes undeviated. Ray parallel to the principal axis will refract and appear to pass through the focal point, front focal point, F1. A ray through F1, sorry, a ray directed towards F2 will, after refraction, pass parallel to the principal axis. After refraction, parallel to the principal axis. All right. And now intersection of these two rays, or out of three, any two rays, I can use to look at the position of the image. I'll use this ray, passing the optic center, goes undeviated. Parallel to principal axis appears to pass through F1, directed towards F2, will pass parallel to the principal axis. And that's where the image is formed. It's virtual and diminished. Yes, exactly. Good students. Coach Srutasya, very good. Excellent. Afia, Harshavardhan, Srutasya, Jhansi. All right. Now, I choose this ray, these two rays, these three rays. I get a image over there. The red color arrow is the image of the yellow colored arrow, which is the object. Now, if you notice one thing, irrespective of object's position, you will get an erect virtual image which is diminished in size in between the focal point and the optic center of the lens. For a concave lens, there is only one case. It is always between optic center and the focal point. The image is always between optic center and the focal point. Geometry children. Object can be anywhere. But the image lies between the optic center and the focal point, F1, front focal point. ఇప్పుడు ఇది చూడండి స్టూడెంట్స్. Now I had an extended object. Now let's say I've got a point object on the principal axis. How will I do? Point object ఉంటే or ఒక I have got a random light ray. I want to trace after refraction, where does it go? Parallel to principal axis will pass through F1. Through F2 will become parallel to principal axis. Through optic center goes undeviated. But how about this ray, which is neither parallel to the principal axis nor passing to the optic center? So how does this behave after refraction? Can Chipakatara students? How does this go? Yeah. Try to think and tell me. Me class textbook on the students. This is from your textbook itself. Okay. Through focus? No. Afia, if it is parallel to the principal axis, it is supposed to go through focus. Right. But this ray is not parallel to principal axis. Some random ray, some inclined ray. How will this behave after refraction through the lens? Lens refraction తర్వాత ఎలా వెళ్తుంది? Yeah, this is there from your textbook itself. Conventional కాదు, like ఒక కార్నర్ లో ఇన్ఫర్మేషన్ ఇచ్చే ఉంది, but it's very important for problem solving. All right. So can you tell you how does it go? Let's see how to trace it. Let's see the steps to trace it. The reason I want you to think about it, read the textbook and think about it, we'll discuss in the next session. But right now, I'll show you the steps to trace the ray, refracted ray after it passes through the lens. What I do, I draw a line parallel to the incident ray passing through optic center of the lens. All right. Steps are, I first draw a line parallel to the principal. I draw a line parallel to the incident ray, which is a random ray. Parallel to that, I'll draw a line passing through optic center of the lens. Now that will go and intersect the focal plane at F1 at some point. All right. This point, and I'll join this point to the point of incidence. This ray, yellow ray. And that is going to be my refracted ray. So given a random ray, how will I trace the uh, refracted ray? I first draw a line parallel to the incident ray to the optic center. That incident ray will go and intersect the focal plane. That vertical line at F1 is focal plane. It's shown as line, but it's a plane when looking from one side of the lens. Alright, that's the plane. That intersects the plane at certain point. When I join that point to the point of incidence, I get refracted ray. This method is called oblique ray tracing. Great. Whatever we have done till now is parallel ray tracing. But oblique ray tracing is also very important and very easy to do. If I have a point object and I wanted to trace the image of the point object on the principal axis, oblique ray tracing will help. Let's see for the concave lens. I've got a ray, some random ray like this. I'll draw a line parallel to this incident ray passing the optic center of the lens. This will intersect the focal plane at F1 at some point. I will join that point to the point of incidence and extend that. And that is going to be my refracted ray. I repeat. I've got a concave lens, F1, and a focal plane at F1. I've got a random ray like this. I draw a line parallel to the random ray passing through optic center of the lens. Once I do that, this line will go and intersect the focal plane at certain point. That point and point of incidence I join. with a dotted line like this and extend it beyond the lens. And that's how I trace the oblique ray. And this is called oblique ray tracing, students. This is there in your textbook. All right. Focus share, but this is there, and this is very important for future exams. TS, TGRJ Sirasina, Polycentrasina, ఇలాంటి questions ఎక్కువ వస్తాయి. రే ట్రేసింగ్ లో వస్తే దెన్ బి ట్విస్టెడ్ క్వశ్చన్ వస్తే ఆబ్లిక్ రే ట్రేసింగ్ లో వస్తుంది. Look at this one. A ray of light AO is incident on diverging lens as shown in the figure. The focal plane of the lens is also given, dotted line. The possible direction of the refracted ray will be. మనం అదే algorithm యూస్ చేసి చేద్దాము. ఆ స్టెప్ సేమ్ స్టెప్స్ విచ్ ఐ జస్ట్ డిస్క్రైబ్డ్. A ray parallel to the incident ray passing through optic center that will intersect the focal plane at certain point. I'll join that point to the point of incidence and extend it beyond the lens. That yellow ray is my refracted ray. All right. So let's see the options now. Which option do you think is closest? Option 3 doesn't make sense at all because it has to get refracted. Ray, when it hits the lens at any point other than optic center, it has to get refracted. I mean, deviated. So what is the option? Correct option over here, students? Yeah, Jhansi, Harshvardhan, Afia, Srutasya, Navtej, Kalyani, Lavanya. Yeah, good. Sridev, absolutely right. Indupriya, very good. It's one. All right. Now let's start with some questions. Here's a question, students. According to sign convention, any doubts over here? Do you want me to repeat? If you don't want this to be redone, you can go to the YouTube channel and listen to the class or look at the video again. All right. So let's go ahead with the questions. So according to sign convention, the distance which is measured in the direction of incident light is taken as positive, negative, any sign, no sign. Yes, Navtej, you want to tell something? You've raised your hand. Yes, Srideep, Indupriya, Gopichan, Navtej, excellent. Very good. So it's positive. Okay. The rays coming from the source parallel to the principal axis of the concave mirror converge at a point. This point is called principal axis focus center of curvature pole. Rays are coming parallel to the principal axis. Note that. All right. So what's the answer for this? Yes, Srideep, excellent. Gopichan, it's not center of curvature. Vasant, good. Okay. Let's see. It's focus, students. All right. Rays parallel to the principal axis, convergent focus. Yes, Navdesh, you have raised your hand again. You want to tell something in chat? You can send it to the chat box. Look at this. In case of a plane mirror, the object distance is dash to the image distance. Plane mirror lo object distance and image distance ki relation em untundi. Inequality untunda, equality untunda. Equal, lesser, greater, none of these. Yes, Harshvardhan, Indupriya, Afia, Gopichan, very good. Meenakshi, Jhansi, Shrideep, very good student. The way you're doing, the way you're answering is excellent. You're not going wrong anywhere. That's very important. But it's okay to be wrong now. Exam lo correct undali students. For that, you have to train yourself. You put నేర్చుకోవాలి. This is not a test. This is a training session. It's equal. Plane mirror చెప్తున్నారు. Magnification is always one for the following mirror. ఇప్పుడు అడిగింది క్వశ్చనే మళ్ళీ అడుగుతున్నారు. Alright. In a different way. Convex mirror, concave mirror, plane mirror, none of these. Magnification is always one for the following mirror. Yes, Meenakshi, Jhansi, Kopichan, Indupriya, Vasant. Navtesh, you have just seen the previous one. It's a plane mirror, right? How can it be a concave mirror? Yes, Srideep, very good. It's a plane mirror. The height of image is double the size of the object. Its magnification is. Magnification formula, that's the easy to students. I'll show you what should be done here. All right, Gopichan. What exactly do you want to be explained again? Yes, Gopichan, you can text me again. We'll do it. But hope you have understood all that you have done till now. All right, good. Okay, look at this. So what's the magnification? Height of the image is double the size of the object. What's the formula for magnification, students? HI by HO. All right. So that should be the answer. And I'll show you solution as well. It is 2. ఎందుకు 2 వస్తుంది? Let the size of the object be x. Height of the object be x. Height of the image is 2x. ఎందుకు 2x రాశారు? Height of the image is double the size of the object అన్నారు. And magnification I know is m is equal to hi by ho, which is 2x by 2, 2x by x, which is 2. All right. Now look at this one. A person is standing in front of a plane mirror at a distance of 10 centimeters. He walked 4 centimeters towards the mirror. The distance between the object and image in the second case is Jatadhara pen, pencil, paper use చేసి చేయండి students. చాలా easy problem, but if you miss that, where to measure from? What to measure? Distance between the object and the image, not the mirror. Object and the image in the second case. All right. So students, after this, we'll go for chemistry section. And Gopichan will definitely do this again. We're going to follow physics. EMI on the tax chapter on the current electricity on the right. We started with optics because it's pretty easy. All right. So students, answer this question. After this, we'll go for chemistry. We'll have a chemistry session after this question. Yeah. So what's the answer? Reading in the chat box. Meenakshi, good. Vasant, Gopichan, Harshavardhan, Gyaneshwar, Indupriya, Harshavardhan again, Meenakshi, Jhansi, Vaishnavi. Yeah, so good. So you have made an attempt, but I'll tell you again, you're going wrong somewhere. It's 12. And how do we do that? He's standing at 10 centimeters from the mirror. He walks 4 centimeters towards the mirror. So image will also move towards the mirror with it by a distance of 4 centimeters. So distance in the mirror and the object is 6. Distance in the mirror and the image is 6. So distance between the object and image would be 6 plus 6, which is 12. 12 centimeters. All right. So students, stay tuned. We have chemistry session now. I request Sonia ma'am to continue the session.
Thank you, sir. Good evening, everyone. And first of all, wish you a happy new year in advance. I'm glad to see you all again today for a chemistry class. Let us quickly do some exercises on atomic structure today. I'll share my screen. Please let me know whether you are able to see it or not. Is my screen visible, students? Can anyone give a thumbs up if you can see the screen? Yes? Okay. So today we will be doing some exercises on structure of an atom. Okay, atomic structure. So we know that atom is a basic unit of matter. See, everything is composed of certain atoms in it. A group of atoms will form molecule, and group of molecules are part of matter. So it's a very basic unit and very good topic which is having a lot of weightage in your even in 10th class and in your higher classes also. So let us do uh, the chapter today and exercise regarding that. So here is our first question. Which of the following is present in a rainbow? So here are few colors which they have mentioned, that is brown, green, maroon and all of them. So which color in specific is present in a rainbow? Can anyone answer this question? So we have Srideep here. He's telling it is green. Good, Srideep. So I think answer is, let us see whether he has done it correct. Yes, green is the answer. How you have done it? It is by using a small rule, that is Vibgyor. Okay, here there is something called as Vibgyor. So V stands for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. So if only these colors are present in the option, then it will be correct. So remaining shades which are mentioned here are by admixture of these colors. So those who have answered it is green are absolutely right. Brown and maroon are not there in Vibgyor. Okay, these are the spectral colors. All the 7 colors are called as the spectral colors. Remaining colors are certain shades of these colors at different wavelengths, but they are not a part of the spectrum. So now let us see the next question. What is the speed of light in vacuum? 3 into 10 to the power of 8 centimeters per second inverse, 3 into 10 to the power of 8 meter per second inverse, 3 into 10 to the power of 8 centimeter plus a second inverse. So what is the right option? Let me see who is going to give the answer for this question. Gopi Chand. Green is the answer. No one has answered this question till now. No idea. So the speed of light in vacuum is 3 into 10 to the power of 8 meter per second inverse. Okay. Meter second inverse is the unit which you have to remember. So only confusion you will get is in the units. So people who has answered it correct are good. Meenakshi Reddy has given option 3. Very good. Those who don't know, just don't confuse for the units here. That is the main thing which you have to keep in mind while solving these type of questions. Next thing, the given number of wave peaks that pass by a given point per unit time is called as. The given number of wave peaks that pass per unit time or per second is called as what? Let us see who will answer this question. I'm giving you a few seconds. Pranita is mentioning it as wavelength. Let us see remaining people who has answered this. Manogya Indupriya is telling it is option A, that is wavelength. Are you all correct? Is it wavelength? Not exactly. Actually, answer is frequency here. So here I am writing the definition of frequency for you clearly. Frequency is defined as the number of wave cycles, the number of wave cycles, the number of wave cycles or peaks passing a point in as per second is known as frequency. So this is the definition of frequency. So if you read the question once again, it is very close to the definition. The given number of wave peaks that pass at a given point per second. So the number of wave cycles or peaks that pass a given point per second is called as frequency. How frequently they are passing. Okay, that is why it is called as a frequency. It is not the wavelength. Okay. So good try. Now let us see the next question. Which of the following relation is correct? So nu is equal to lambda by c, or c is equal to nu by lambda, or nu is equal to c by lambda, nu is equal to 1 by lambda. Which is correct? Let us see who will answer this question. Meenakshi. Remaining people? Gopi Chand. Answer is not 4. Pranita is telling it is 2. Wrong. So the right answer is nu is equal to c by lambda. What is this nu? Nu represents frequency. Okay. Frequency. So what is frequency? Frequency is equal to c by lambda, where c is equal to speed of light in vacuum. Speed of light in vacuum. That is what we have seen just now. 3 into 10 to the power of 8 meter second inverse. So this is the speed of light in vacuum divided by lambda, that is wavelength. So this is the right expression. So frequency is equal to speed of light in vacuum divided by wavelength, that is lambda. Next question. The range of colors or wavelength covering red color to violet is called as which? Emission spectrum, absorption spectrum, visible spectrum, or line spectrum. What is the right answer? Okay. Let us see anyone answered this question. Gopi Chand is again. Remaining people? Fourth? No. So, as I have mentioned, so the VIBGYOR range, VIBGYOR, this range is called as the visible range. So you can see all the 7 colors in atmosphere, no? So if starting from red, red is the highest wavelength, highest wavelength, and violet is the lowest wavelength, lowest wavelength. So starting from red to violet, this range of colors can be visible for the human eye. So that is why this spectrum or the 7 colors which are available are known as the visible spectrum or visible range. I think it is clear for everyone. So remember VIBGYOR, if you are remembering that, if those colors are there in the question, then it definitely belongs to the. Now let us see what is the value of Planck's constant. First of all, tell me what is meant by Planck's constant. Can anyone tell what is Planck's constant? Okay, guess the answer first. If you are able to answer it, then we will see about this Planck's constant for a second. Vaishnavi is telling it is 3. Remaining people? Yes. Any answers? Again, Vaishnavi has replied. Option is 2. So let us see what is the right answer. Yes, it is absolutely correct. Option 2 is correct. Value of Planck's constant. So this Planck's constant was introduced in the year 1900 by, please excuse me, Planck's constant was introduced in the year 1900 by Max Planck. Max Planck. So what this Max Planck done? He has given certain like a behavior of energy, like how energy behaves, like quantumization of energy, and he has given so many postulates also regarding that. In the due process, he has mentioned a wonderful equation that is equal to E is equal to h nu. Okay, where E is energy of photon, E is energy of photon, and h is the Planck's constant what we are mentioning here. Planck's constant which we are mentioning, and nu is the frequency. Okay. So what is the actual meaning for this equation? Whenever the energy of photon increases, frequency also increases. But for equating that proportionality, he has used a constant called as Planck's constant. What is the value of the Planck's constant? 6.626 into 10 to the power of minus 34 joules per second. Next question. Which of the following color is not present in rainbow? Simply remember VIBGYOR and solve this. VIBGYOR is the visible color range which is present in a rainbow. So which of these following colors is not present in the rainbow? Let us see who will answer this question. Jhansi. Answer 1 is blue is there, no, in rainbow. Tell me which color in the option. Yes, Vaishnavi has mentioned is correct again. Pink is the color which is not present in the rainbow. Okay, pink is the option, right option. Pink is the color which is not present in rainbow. Now let us go to the next question. Electromagnetic energy can be gained or lost in discrete values and not in a continuous manner. This is an important postulate given by the following scientists. So you have to identify which scientist has given this. Planck, Rutherford, Einstein or Bohr. Let us see who will answer this question. You're being little late, Kopichand. Remaining people are being fast. Okay. Again, Srutasya has mentioned it correct. That is Planck. So Planck is the person who has given this wonderful postulate regarding the electromagnetic energy. That electromagnetic energy can be gained or lost in discrete values and not in a continuous manner. Okay. Now let us see the next question. The path of an electron around the nucleus is called as what? Here there are 3 options and all of the above. So let us see who will answer this correctly. Vaishnavi. Vaishnavi has mentioned it as orbit. Remaining people? Shell. Okay. I think it is all of the above. Why? Because see, orbit or energy level or shell, all the three will show the position of or the path of electron around the nucleus. So if there is a nucleus here, there is an electron revolving around the nucleus. This is called as energy level. Energy level. This is called as orbital. This is also called as shell. So all three names are signifying the same thing. Okay, it is just the path or the rotational axis on which that electron will rotate. Is it okay? So the next question. Orbits are called as stationary orbits because they have what? Fixed energy, radius, both energy and radius or none. Let us see who will answer this question correctly. Yes, Meenakshi has mentioned option 2. Vaishnavi is telling it's option 1. Radius. Rutasya is telling it is radius. Let us see what is the right answer. Yes, it is the energy. Okay. Orbits are called as stationary orbits because they have fixed energy. You can never tell that orbit itself is changing. Electron is jumping from one orbit to another orbit when it is reaching its excited state. But the energy path will remain constant. That is why orbits are always stationary because of fixed energy levels. That is why they are called as energy levels. Okay, other name for orbits is energy levels. Why? Because they are having one significant energy within them. Now let us go to the next question. Which of the following is not included in Bohr's atomic model? Stationary orbits, energy of orbits is quantized, elliptical orbits, absorption of energy when an electron jumps from lower orbit to higher orbit. Which of these following postulate is not mentioned in Bohr's atomic theory? Let us go with Sutasya's option. It is option number 3. As per Sutasya, Meenakshi is mentioning it as option 1. Vaishnavi has mentioned it as option 3. So the majority wins. It is option 3. So elliptical orbit is a postulate which was given by another Somers, there is another person who has mentioned this postulate. It is not by the Bohr's atomic model. Okay, Bohr's atomic model does not explain about the elliptical orbitals. We have another bit regarding this elliptical orbital. That is why I'm not mentioning the person's name, because I will be the person who will answer before itself. So now we will have a question regarding that also. Then we will discuss about that. Which of the following is a defect in Bohr's theory? Which of the following is a defect in Bohr's theory? It could not explain the spectrum in atoms containing more than one electron. It could not explain fine structure of the spectrum. It could not explain formation of chemical bonds and all of the above. ఇందులో ఏదమ్మా correct answer? Gopi Chand 3. Srutasya is telling it's all of the above. Chutama right answer ఏంటో? Yes, it all of the above. All of them are the defects in Bohr's atomic theory. Bohr's atomic theory ఏం ఎక్స్ప్లెయిన్ చేయలేకపోయింది? స్పెక్ట్రమ్ ఇన్ ఆటమ్స్ కంటైనింగ్ మోర్ దాన్ వన్ ఎలక్ట్రాన్. ఒక ఎలక్ట్రాన్ కన్నా ఎక్కువ ఎలక్ట్రాన్స్ ఉన్న ఆటమ్స్ లో స్పెక్ట్రమ్ అనే కాన్సెప్ట్ ని ఎక్స్ప్లెయిన్ చేయలేకపోయింది. ఇట్ కుడెంట్ ఎక్స్ప్లెయిన్ ద ఫైన్ స్ట్రక్చర్ ఆఫ్ ది స్పెక్ట్రమ్. స్పెక్ట్రమ్ తాలూకు ఫైన్ స్ట్రక్చర్ ని ఎక్స్ప్లెయిన్ చేయలేకపోయింది. ఇట్ కుడ్ నాట్ ఎక్స్ప్లెయిన్ ద ఫార్మేషన్ ఆఫ్ కెమికల్ బాండ్స్. కెమికల్ బాండ్స్ ఫామ్ అవ్వలేవని, ఎందుకు అవ్వట్లేదు అనేది ఎక్స్ప్లెయిన్ చేయలేకపోయింది. Next, this is the question. That is why I did not give the answer before. The elliptical orbits were proposed by Bohr కాదని మనకి ఇందాకనే అర్థమైపోయింది. ఇప్పుడు చెప్పండి. Yes, Gopichand, I will be answering your question. చెప్పండి అమ్మా. You just put in the chat box. What is the right answer? Yes, Gopishant has given all of the above correct for the previous thing. Now you tell me the answer for this question. ఇందుప్రియ సోమర్ఫీల్డ్ అని చెప్పింది. మిగతా వాళ్ళు Shrutasya also Somerfield. So I think this is the right option. Somerfield is a person who has postulated about the elliptical nature of the orbits. Okay. Next question. The fine spectra of hydrogen atom is explained by. ఇక్కడ ఉన్న సైంటిస్ట్ లో ఏ సైంటిస్ట్ మనకి ఫైన్ స్పెక్ట్రా ఆఫ్ హైడ్రోజన్ ఆటమ్ ని ఎక్స్ప్లెయిన్ చేశారు? రూథర్ఫోర్డ్, బోర్, డి బ్రోగ్లీ ఆర్ సోమర్ఫీల్డ్? హూ ఇస్ ద పర్సన్? Come on, you have very short time. Fastest finger first. People who are confident, let me see how many of you are confident regarding this topic today. Option 3, డి బ్రోగ్లీ అని ఇచ్చారు కొంతమంది. Remaining people, Somerfield. Let us see whose answer is correct. Somerfield is the right answer. Okay. So, the fine spectra of hydrogen atom. Fine spectra of hydrogen atom explain చేసింది ఎవరమ్మా? ఈ కాన్సెప్ట్ ని సోమర్ఫీల్డ్ అనే పర్సన్ ఎక్స్ప్లెయిన్ చేశారు. For a given circular orbits, number of elliptical orbits possible are. సర్క్యులర్ ఆర్బిట్స్ మనకి తెలిసినప్పుడు నెంబర్ ఆఫ్ ఎలక్ట్రికల్ ఆర్బిట్స్ మనం ఎలా క్యాలిక్యులేట్ చేస్తాము? ఇందులో ఏ రిలేషన్ యూస్ చేస్తాం? n-1, n+1, 2l+1, where n is the principal quantum number. ఓకే, హర్ష ఆప్షన్ 3 అని చెప్పారు. వసంత్ 3332, what is that? Pooja option 2, Prasad option 3. So let us see what is the right answer. I got a mixed answer. 2 is the right answer. n-1. So whenever you get the principal quantum number, which shell it belongs to, you have to subtract -1 to get the number of elliptical orbitals present. Okay. Any elliptical orbitals ఉన్నాయనేది అలా తెలుస్తుంది. Quantum theory was proposed by. Who has proposed the quantum theory? Rutherford, Thomson, Planck, Bohr. Who is the person who has mentioned about the quantum theory? Yes, let us see who is the person answering this first. Meenakshi is telling it is Bohr. Harshavardhan. Shrutasya is telling answer is Planck. Again, mixed response. So Planck is the right answer. So quantum theory was proposed by Planck. Planck ఇందాకలా మనం ప్లాంక్ చెప్పిన ఎనర్జీ ఈక్వేషన్ చూసాం కదా. ప్లాంక్ మెయిన్ క్వాంటమ్ మెకానిక్స్ ని ఇన్వెంట్ చేశారు. ఐ మీన్ లైక్ ఎనర్జీ పాకెట్స్ కింద ఎనర్జీ ఆఫ్ ఏ ఫోటాన్ is mentioned as quantum. Okay, so that was introduced first by Planck. Next question. The region of space around the nucleus where the probability of electron is called as. Probability of finding electron is called as. So ఎక్కడ మనం ఎలక్ట్రాన్ ని ఫైండ్ చేయగలుగుతాం? ఆర్బిట్లోనా, ఆర్బిటాల్లోనా, న్యూక్లియస్లోనా? We will obviously find it in orbital కదా. ఇందాకలా ఆన్సర్ కనిపించింది కాబట్టి ఐఎమ్ నాట్ టేకింగ్ ద ఆప్షన్స్. నెక్స్ట్ క్వశ్చన్ ఈస్ షేప్ ఆఫ్ px ఆర్బిటాల్ ఈజ్. p ఆర్బిటాల్ యొక్క షేప్ ఏంటి? స్పెరికలా, డంబెలా, డబుల్ డంబెలా, సర్క్యులర్? Let us see who will answer it correct. Shrutasya. Option 2, that is dumbbell. Harsha. Option 2. Meenakshi, dumbbell. So most of you are answering it as dumbbell shaped. Yes, that is the right option. Dumbbell is the shape. Spherical is representing s orbital. Dumbbell is for p orbital. Double dumbbell d orbital. Okay, SPDF లో మనకి SPD will represent these structures. Okay. Which of the following is not true for p orbital? Shape is dumbbell shape. having one nodal plane. P orbitals are perpendicular to one another. Lobes orient between the axes. Indulo ఏది wrong for p orbital? Let us see who will answer this question. ఇందులో ఏదమ్మా wrong? No idea? Harsha is mentioning it as option 3. Okay. I think it is the right answer. Lobes orient in between the axes. Okay, lobes orientation between the axes అనేది it is not possible in case of the p orbital. Why? Because p orbitals are oriented along x, y and z axis. Okay, lobes అనేవి x axis మీద y axis మీద z axis మీద orient అయి ఉంటాయి కాబట్టి between the axis అనేవి orient అయి ఉండవన్నమాట. Next question. Size and energy of orbit are given by which quantum number? Principal quantum number n, or azimuthal quantum number L, or magnetic quantum number S, ms, or spin quantum number, which will be representing magnetic quantum number mn or ms. So which is the right option among these? Size and energy ఏం చెప్తుందమ్మా? Srutasya is telling it is principal quantum number. Let us see what is the right answer. Yes, principal quantum number will explain about the energy. Please excuse me. Energy of the orbital. Azimuthal quantum number ఏం explain చేస్తుంది? What will azimuthal quantum number explain? Shape of the subshell. Okay, shape of subshell. Magnetic quantum number will explain orientation. Orientation in space. స్పేస్లో ఎలా ఓరియంట్ అయ్యింది అనేది చెప్తుంది. స్పిన్ క్వాంటమ్ నెంబర్ ఏం ఎక్స్ప్లెయిన్ చేస్తుంది? డైరెక్షన్ ఆఫ్ స్పిన్. డైరెక్షన్ ఆఫ్ స్పిన్ యాంటీ క్లాక్ వైజ్ గానా లేదా క్లాక్ వైజ్ గానా అనేది ఎక్స్ప్లెయిన్ చేస్తుంది అనమాట. నౌ ద సబ్షెల్స్ ఇన్ ఎమ్ షెల్. ఎమ్ షెల్లో ఎన్ని సబ్షెల్స్ ఉన్నాయి? ఇట్స్ అన్ ఈజియెస్ట్ క్వశ్చన్. ఎమ్ షెల్లో ఎన్ని సబ్షెల్స్ ఉన్నాయమ్మా? Harsha, I'm taking your answer. Option 3. Remaining people? Vasant? Option 1. So M shell is having 3. 3 is the right answer. K shell is having only 1s configuration. L shell is having 2s 2p configuration. M shell is having 3s 3p 3d. So 3 is the right answer. Next question. So we have only 5 more minutes. We will do 2 or more questions and we will stop for today. L is equal to 1. Name the subshell. So if the azimuthal quantum number is 1, then what is the subshell? Let us see who will answer it correctly. So it is P. So yes, you are absolutely correct. So if azimuthal quantum number is 0, then it is S shell. If it is 1, it is P shell. If it is 2, it is D shell. And if it is, as it is 1 in the question, so it is the P shell. Shape of a subshell is given by which quantum number? ఇందాకలా మనం అన్ని చూసాం కదా, అందులో shape of a subshell ఏ quantum number చెప్తుందమ్మా? N is for principal quantum number, L is for azimuthal quantum number, ML is for the magnetic quantum number, and MS is for the spin quantum number. ఇందులో ఏ quantum number shape of the subshell చెప్తుందమ్మా? Let us see who will give the right answer. It is the azimuthal quantum number which will be telling about the shape. Number of subshells in a shell is equal to. What is the number of subshells in a shell equal to? What is the formula? Let me see who will answer it correctly. Number of subshells in a shell చెప్పండమ్మా. What is the right answer? Shrutasya, L plus L. So L plus 1. Let us see what is the right answer. N. Okay. The number of subshells in a shell is equal to principal quantum number. The maximum value of azimuthal quantum number for n is equal to 4. So what will be the maximum value of azimuthal quantum number for n is equal to 4? Can anyone answer this question? Vasant. It is 4. So let us see what is the right answer. 3. 3 is the maximum value of azimuthal quantum number for n is equal to 4. Maximum value of L will be equal to n minus 1. So 4 minus 1 will be 3. So 3 is the right answer. Which of the following quantum number gives the orientation? We have discussed before only that magnetic quantum number will give the orientation. So which of the following quantum numbers is not possible? ఈ 4 ఆప్షన్స్ ని బాగా అబ్జర్వ్ చేసి which is the odd one out చెప్పండి. Let us see who will answer this question. Shrutasya is being very active. Now I'll take another. Indupriya is mentioning it as option D. No. Think again. సో ఒకటి గోల్డెన్ రూల్ గుర్తుపెట్టుకోండి. వెన్ దెర్ ఆర్ సెట్ ఆఫ్ క్వాంటమ్ నెంబర్స్ గివెన్, ఏ రెండు క్వాంటమ్ నెంబర్స్ ఈక్వల్ వాల్యూస్ని చెప్పలేవు. ఓకే, ఇక్కడ మీరు చూస్తే ప్రిన్సిపల్ క్వాంటమ్ నెంబర్ అండ్ అజిముతల్ క్వాంటమ్ నెంబర్ రెండు కూడా 3 ఉన్నాయి. సో ఇన్ సచ్ కేసెస్ మనం ఈ ఆడ్ వన్ అవుట్ కింద ఈ ఆప్షన్ ని సెలెక్ట్ చేసుకుంటాం. మిగతా అన్ని మీరు అబ్జర్వ్ చేస్తే సేమ్ క్వాంటమ్ నెంబర్స్ పెద్దగా లేవు. ఇక్కడ మనం చూస్తే క్లియర్ గా ప్రిన్సిపల్ క్వాంటమ్ నెంబర్ అండ్ అజిముతల్ క్వాంటమ్ నెంబర్ రెండు కూడా సేమ్ ఉన్నాయి. Next question. Orbitals with same energy are called as. What are the orbitals with same energy? Tell me what is the right answer. Same energy in orbitals name antamamma. So option is degenerate orbitals. Whenever two orbitals are having same energy, we call them as degenerate orbitals. What are the maximum number of electrons present in subshell with L is equal to 3? సింపుల్, మనం ఇందాకలానే ఫార్ములా చూసాం కదా. చెప్పండి దీనికి ఆన్సర్ ఎవరు చెప్తారు కరెక్ట్గా? శృతాస్య, ఆప్షన్ 3. Yes. So here L is equal to 3 is for D. So in D, 10 electrons can be accommodated. Okay. So Shrutasya is being very active and sharp. So that's all for today. Every one of you have answered very well, participated very well, and I think we have covered our time span also. So Shrutasya is very active. So you have answered. The speed is super. Even Gopichand has answered very well. Like I can recollect few names. Indu Priya is being very active in all the classes, and Vaishnavi. So remaining Vasant also a couple of answers were correct. సో మీకు ఐ థింక్ నా ఎక్స్ప్లెనేషన్ అర్థమవుతుంది. ఇంకా ఏమైనా డౌట్స్ ఉన్నా కూడా యూ కెన్ రీచ్ అవుట్ టు మీ ఇన్ ఫర్దర్ క్లాసెస్. ఇవాళకైతే మనం ఇక్కడితో క్లోజ్ చేద్దాం, బికాస్ ఐ థింక్ ఎవ్రీ వన్ విల్ బీ ఇన్ ద సెలబ్రేషన్ మోడ్ ఆల్సో. Everyone, I wish you all the best for everyone, that this coming year will be a great success for you all in your academics. Okay, follow the same all the classes with same concentration, and like subscribe to our YouTube channel. I had a good day with you all. Thank you so much. Happy New Year once again. Chandrika ma'am. Chandrika ma'am, over to you.
Yes, ma'am. Thank you, ma'am.
Thank you so much.
Yes, students. Bye, everyone, students. Again, we have class tomorrow. Yeah. Again, we have class tomorrow. Bye, everyone.